This equation is pretty difficult to solve, but I promise you, if you studied a lot of algebra, you're more likely to get it wrong. Now, why am I saying that? Because you're likely going to overthink the solution. But if you're thinking in terms of basic math, you'll probably figure out the answer pretty quickly. So, of course, I'm going to break everything down here in just 1 second. And by the way, feel free to use a calculator and a little bit of a hint. If you have a graphing calculator can actually help you find the solution to this equation. All right, so I'm going to get into all of this in just 1 second, but first let me quickly introduce myself. My name is John, and I have been teaching math for decades. And if you need assistance in mathematics, check out my math help program at tcmathacademy.com. You can find a link to that in the description below. And if this video helps you out, or if you just enjoy this content, make sure to like and subscribe, as that definitely helps me out. Okay, so what do we have here? Well, we have an exponential equation with two bases. So we have 3 to the m power minus 2 to the m power is equal to 65, and we're trying to solve this equation for m. All right, so what is the answer to this equation? Well, let me go ahead and just tell you, m is equal to 4. Now, if you got that right, that is fantastic. Now, some of you are going to be very frustrated. You're like, hey, Mr. YouTube Math Man, I'm really good at algebra. I know a lot of math, and I just don't understand how you solve this equation, right? Well, that's because you're taking an algebraic perspective as the only way to figure out the solution to this equation, all right? And of course, I'm going to explain myself in just 1 second. Now, other people who might only know some basic math and some basic power things, if I gave you a problem like 3, well, let me write this a little bit better. 3 to the m power is equal to 9. If this was the problem, what we technically have here is an exponential equation. But some people who only know a little bit of basic math might be like, I don't know, maybe I could just plug in some numbers and yeah, 3 to the first power, that's 3. 3 to the second power, well, that's 3 times 3, that's 9. Well, maybe m is equal to 2. Well, that in fact is the correct solution. So you could do the same thing here. Or you could be like, all right, well, I don't really know the algebra to solve this problem, but I could test some numbers here to see if we can make this thing work, right? So we can kind of start off, let's start off with 2. So 3 squared minus 2 squared. So if m is equal to 2, this thing should balance, but it doesn't, right? So 3 squared is 9, and 2 squared is 4. So 9 minus 4 is 5. That's not 65. But let's go ahead and continue to increase the power. So we'll go from 2, right? So then maybe 2 to 3 to 4. Well, as you continue this little trial and error, you'll run into 4, and you'll notice that 4 works, right? So 3 to the fourth power is 81. 2 to the fourth power is 16. 81 minus 16 is 65. So therefore, m is equal to 4. All right, so this is how you can solve this equation. And a lot of you out there that know a lot of algebra might be saying, hey, Mr. YouTube Math Man, that's not fair. You didn't really use any algebra to figure this out. Well, you don't have to use algebra to determine the solution to an equation. Now, you want to back up your answer with algebra. We'll get to that in a second. But, never kind of over complicate looking for an answer. In other words, if your algebra isn't working, try to think outside the box and at least get the answer. Because here you might say, all right, well, I know m is equal to 4, so let me see if I can back this up with some algebra. So this is the first technique that can use is, to solve this equation, which is basically kind of like a guess and check method. Now let's talk about another technique. Now, I did indicate that you can use your calculator, and if you have a graphing calculator, maybe you want to follow along. I'm talking about something like a TI-83, TI-84. Any graphing calculator will do. And if you don't know how to use a graphing calculator or don't have one, that's not a problem. I'm going to explain to you what happens when we graph this equation. All right, so what we're going to have to do here is move the 65 over. So we're going to look at this as an equation, y equals 3x minus 2x minus 65, right? So if you're pretty good in algebra and you know how to use a graphing calculator, So we're just going to use the variables x instead of m so we can plot this on an xy plane. All right, so when we graph this and we type this into our graphing calculator, we're going to see the graph of this equation, and it's going to look something like this. Now, of course, you can, do this yourself if you have a graphing calculator, but basically what we're going to end up with is something along these lines right here. All right, so here's the XY axis, and when you plot this thing, you're going to get a branch of this function, or this graph actually, or equation, and it's going to cross through the x-axis at 4. You'll be able to see that pretty clearly on your graphing calculator, indicating that 4 is the real number solution. You won't see any other part of the graph. So 4 is your solution. You're like, all right, well, the graph is crossing here at 4. Let me go ahead and check this. Oh, indeed, it works. So these are two methods that you could use to solve this equation. But the most exciting and most challenging part of this problem is the algebra. And if you're using algebra to solve this problem, this is a common way that people look. They'll be like, I don't get it. I just don't understand what to do. I am totally lost. Well, let's go ahead and get into this right now. And we have a lot to cover. And we're going to have to use some creative algebra to solve this thing. All right, but nothing that a first or second year algebra student couldn't handle. But we're going to have to really kind of think outside the box. So let's take a look at this equation. So what do we have? Well, we're trying to solve for the variable in the exponent location. So this is an exponential equation of some sort, very much like 3 to the m is equal to 9. Well, this is pretty easy because we're like, oh, well, m is equal to 2. But if this was like 3 to the x power is equal to 12, well, this is more interesting. And to solve an exponential equation like this, you're going to have to use logarithms, all right? So let's go ahead and think about this. And you might be saying, all right, well, logarithms, and I want to use logarithms, but we kind of run into some roadblocks here with the logarithms. I'll explain myself in a second. But I'm kind of getting a little bit ahead of myself. Another thing that some people might think they can do is like, well, we have m. Maybe we can factor out m here, okay, this power. But that is not a property of powers and exponents. You cannot do this in mathematics, right? So like right here, if we have 3 squared minus 3 squared minus 2 squared, obviously this is 9 minus 4. This is equal to 5, right? So we don't have a property where we can factor out the exponent this way because this is a difference. So we can't go like, all right, 3 minus 2 squared and think that we can distribute this 2 back in because 3 minus 2 is 1. 1 squared is 1. Obviously, this is not 5, right? So we cannot do this. So what do? We're like, I don't know. I would like to use logarithms, but the logarithms only really kind of work with one power. Okay, so let me show you here in a second. So here is our equation, and you're looking at it, you're like, all right, it's an exponential equation. I'm trying to solve for the variable and exponent spot, but we have two different bases. But if we only had one base, like 2m is equal to 65, we could use logarithms, and the way you would do that is you would take the log of both sides, like the common log, then you would use a property of logarithms to drop down the m in front of the log. So m times log 2 is equal to log 65. These are just values, and then we can solve for m by dividing both sides of the equation by log 2 and then plugging this into our calculator. Now, a lot of you probably know this. You're probably pretty good in algebra. You're like, yes, Mr. YouTube Math Man, this is way I want to go, but I still can't figure this out. Well, that's because when you're talking about taking the log of both sides, all right, you're only concentrating on one base and one exponent. Here we have two bases, right? So we're going to have to kind of think of another strategy. So what can we do? Well, we can't do this again. We can't factor out the m. We already talked about this. So we're kind of lost. We do know the answer, though, is 4. So what is a math person to do? Well, you're going to have to get a little creative here. And here is the key, a big hint in terms of figuring out this problem. All right, so what properties of powers and exponents do we know? Well, there's about 5, but this is the one that really is going to help us unlock the key to the solution. So when you have a power to an exponent, like a to the m, this is the property, a to the m to the n is equal to a to the m times n. So for example, if you have 2 squared to the third power, this is equal to 2 to the 6, right? And it makes sense because we're taking 2 squared and we're cubing it. So 2 squared times 2 squared times 2 squared will end up with 6 2's, right? 2 times 2 times 2 times 2 times 2. I think that's 6. 1, 2, 3, 4, 5, 6. So 2 to the 6th power. So this is the property that we want to think about. Now, I'm going to give you an opportunity to use this property to rewrite this expression right here. And this is going to be pretty interesting, even if you're good at algebra. You're going to be like, all right, I'm not quite sure how to do this. Well, let's go ahead and take a look at that right now. All right, so here we go. So 3m minus 2m is equal to 65. We could do this. We could think of 3m as 3 to the m over 2, okay? But we're going to square this because we know that we have this property that an outside exponent times the inside exponents. We're allowed to do that, but now we have a number on the outside, not an m. So we're kind of changing this from an exponential equation to a different type of an equation. So we have 2 times m over 2, that is m, right? So m over 2 times 2 over 1, 2's cross cancel, we get back to m. So we could rewrite these powers in such a way where we have a 2 on as the exponent. So now we have this stuff on the inside. So we're not really kind of dealing with an exponential equation right now. Now we're dealing with something else. Now I'm going to give you another hint. There's a pattern going on here. So we have something squared minus something else squared. All right, what could this be? Well, I'm going to be kind of using first year algebra here. So something squared minus something else squared. What is this? What are we talking about? Well, we're talking about the difference of two squares, right? So something squared minus something else squared. So it's something is, well, we could just use a variable like a, and something else we can use a variable like b. It doesn't make a difference. We're talking about two different things that are squared and we're subtracting them. So we have an a squared minus b squared situation, and we can use the difference of two squared formula, which is a squared minus b squared is equal to a plus b times a minus b as a formula to figure this expression out. So now we got some momentum going, but things are going to get much more interesting. So if you're saying, all right, Mr. YouTube Math Man, I'm still, struggling, but I'm kind of getting it. Well, don't feel too bad. This is a very unique type of problem and solution. All right, so here is our situation. So we have 3m to the m over 2 squared minus 2 to the m over 2 squared is equal to 65. So we're going to think of this as like an a minus b, a squared minus b squared situation on the left-hand side. So let's go ahead and let the variable a, we'll let a represent this whole thing right here, 3m over 2, 3 to the m over 2 power. And we'll let b equal 2 to the m over 2 power. And we're going to do some substitution here. So let's go ahead and substitute in a and b for these powers. So this is what we're going to get. All right, so we're going to plug in, or we're going to replace all of this with a, and we're going to replace all of this with b. So now we're down to a squared minus b squared is equal to 65, and we know the difference of two squares is a plus b minus a minus b is equal to 65. So some of you might be exacerbated at this point. You're like, all right, Mr. YouTube Math Man, continue on because I still don't get how we're going to solve this because we have two variables and one equation. Yes, you're right. We don't have a system of equation. We have two variables, but only one equation. How are we going to figure this out? Well, we're going to have to use some more creative thinking. And let's just let a number like 1 represent one of these variables. So let's let like b equal to 1 because what we have here is a number plus another number, okay? When we add these together and then we multiply those same numbers, but we take the difference this time, somehow we're going to end up with 65. And because we have an integer value, we could probably figure this thing out with integers. So let's just kind of let one of the variables here represent one number. We'll just plug in a number and see what happens and see what we get with the other number. okay, because we're looking for two numbers, right? So let's let b equal to 1 and see where this takes us. All right, so if we let b equal to 1, we end up with a plus 1 times a minus 1. Remember, we're going to substitute a1 for b. And when we do the math here, we're going to end up with, remember, a plus b times a minus b is a squared minus b squared. But you can just do the FOIL method. And when you multiply back in, we end up with a squared minus 1 is equal to 65. Pretty interesting. Looks like we can solve for a. But when we do this, we're going to end up with a squared is equal to 66. We're going to add 1 to both sides. And we're kind of like bummed out a little bit. We're like, oh, I don't know about this, Mr. YouTube Math Man, because I can't really take the square root of 66. I can, but it's not a nice perfect square like 4, 9, 25. But we can fix this up because, remember, we decided what b is equal to. We just let b equal to a 1. So let's let b equal to another number. But what other number? Well, we have to add something to both sides of this equation. In this case, when we let b equal to 1, we have to add 1 to both sides. So what can we add to this 65 to make it a better number, an easier number to solve this equation, right? Well, what's the next perfect square after 65? Well, you're thinking, well, I'd like to make this 64, but we can't because this is a squared minus b squared. We're going to have to add. So how about 81? That comes after 65. That's the next perfect square. So if we add a 16 to the 65, we will get, well, this is 11. This is going to be 81. So if we end up with the 81 over here, now we can solve for a. A will be equal to positive or negative 9. Okay, so that's going to be much better because now our b and a values will be integers. But we need to figure out, all right, well, if we need to get a 16 over here, how do we get a 16 over, as a b squared? Well, to get a 16 as our b squared, we're going to have to let b equal to 4, okay? Because we plug in 4 right here, we eventually get this b squared, right? B squared or 4 squared, which is 16. So a squared minus 16, when we add it, we'll get that 81. All right, now I know a lot of you are like, okay, Mr. YouTube Math Man, this is why I don't like math. Can you please hurry up and finish up? All right, we're almost there. So a squared is equal to 81. Let's go ahead and let b, instead of 1, let's let it equal to 4. All right, so let's do the math. I already kind of went through it. So we have a squared minus 16 is equal to 65. So a squared is equal to 81, and a now, we can just take the square root of both sides, is equal to positive or negative 9. All right, so let's go ahead and see what happens here. All right, so we have two solutions, a positive and negative, but let's think about the positive root here. So let's remember, we let a equal to 3 to the m over 2. And we just solved for a when b was equal to 4, all right? So a is positive or negative 9. So let's go ahead and solve now for m and when a is 9, because we now know that a is positive or negative 9. So here's what we end up with. We have 3 to the m over 2 is equal to 9. So this lovely little equation we can easily solve because 9 is the same thing as 3 squared. So if we take a look at these exponents, we have m over 2 and 2. So these exponents must be equal because the bases are the same, right? So 3 to something, 3 to some power is equal to 3 to the second power. Well, these exponents must be the same. So let's go ahead and set those exponents equal to one another. So m over 2 is equal to 2. So to solve this equation, we just simply cross multiply. So m is equal to 4, which is the answer we were looking for. Now, if you use b is equal to 4 because we set b equal to 4, you would have seen also that m will work out as 4 as being our answer as well. All right, now there's a few little things that I'm not going to continue to cover here because I just don't want to make this video too much longer, but this in essence gives you the gist on how to solve this equation. Now, again, even like top-notch algebra students could struggle with this particular problem because they're kind of focused in on the exponential equation part of it, right? But remember, we need to set the log of, when you're solving an exponential equation, you need to take the logarithm of both sides. And even if you look at the property of logarithms, it's really not going to help you out So you have to get creative. And sometimes you don't need, that much advanced algebra in order to figure out the solution, but you do need to be creative about it. And one thing, again, here is that even those of you that really don't know too much math, if you just kind of use a common sense approach, you could have still figured out the problem. But this is a fantastic little challenge problem because it gives people at all levels of math an opportunity to be able to solve it. Whether you know basic math, you just test some numbers, or if you have your graphing calculator and you're good with using a graphing calculator and you know the relationship between the graph and the x-intercepts and the solution, or you are just an algebra genius, whatever way you solve this, that's fantastic. But hopefully this video helped you out. And if that's the case, don't forget to like and subscribe. And with that being said, I definitely wish you all the best in your math adventures. Thank you for your time and have a great day.